Section 2.4, Statistical Graphs. So we've worked with histograms already based on frequency distributions, but of course there are several other ways and other types of graphs to visually represent data. We're only going to take a look at a few of them in our notes, so be sure to read through all the different types of graphs and when they're most likely to be used. Below is a frequency table or frequency distribution and a histogram of the number of cardiograms performed each day for 20 days in an outpatient testing center. So this is what we learned in the previous section, but it's already been done for us. So here's our class and the class boundaries. And I know this is a little odd, but remember we go outside of the original class a little bit to get that class boundary. So that's why we have that negative 0.5 and our frequencies. And here's a histogram based on this frequency distribution up above. And this is a little bit off. It's probably due to some rounding from the program that I use, because this 10 should really be 9.5, the 20 should be 19.5, and so on. But I'm assuming that the program probably rounded for some reason. But basically, this histogram is produced from this frequency table here. Now let's take a look at some other graphing techniques. So another graph that can be plotted from a frequency table is what's called a frequency polygon. A frequency polygon places a dot above the midpoint of each class. So the histogram is based on the class boundaries, but a frequency polygon will be based on the midpoint. The height of the dot corresponds to the frequency, just like the height of the bar, and all the dots are connected with straight lines, where the first and last lines always touch the horizontal axis. So in example 1, we're going to determine the midpoint of each class in the table above the cardiogram data and use that information to graph a frequency polygon over the histogram. And we're going to do that on purpose to show some relationship between a histogram and a frequency polygon. So to find the midpoint, we're going to add the class boundaries, the lower class boundary and the upper class boundary, and then divide by 2. So for that first class boundary, I have negative 0.5 plus 9.5, which gives us just an even 9, divided by 2 is 4.5. So the midpoint for that first class is 4.5. Then I would do the same thing for the next class, 9.5, and this time I'm going to type it all in as one statement. Parentheses 9.5 plus 19.5 divided by 2, and that gives me 14.5. And perhaps by now you can see a pattern. This one will be 24.5, and then 34.5, 44.5, and 55.5. So our midpoints are about right here. Remember, our graph is a little bit off, but there are our midpoints. So 4.5, 14.5, 24.5, and so on. And for my frequency polygon, I'm going to put, I still want a dot at the height, just like with a histogram, but it's going to be centered right over that midpoint. So then I connect those dots. Remember that the first line should be touching the horizontal axis, and then we just connect all of our dots. And then after the last point, we want to make sure to go back down to the horizontal axis. So they're superimposed right now, and that was on purpose just to show you how a frequency polygon shows us pretty much the same information as a histogram, but we're using these dots and lines instead of bars. Having said that, what are some similarities and differences between a histogram and polygon? So similarities they both show or display information from a frequency distribution or frequency table. For a frequency polygon, classes are shown at the midpoint. But for a histogram, classes are shown at the endpoints or class boundaries. So coming from the same table of information, but they're just displayed slightly different. Okay, and just to note, we can also produce a frequency polygon based on a relative frequency table, like we saw with a relative frequency histogram. Just as with histograms, a relative frequency polygon will have the same shape as a frequency polygon based on the same data, but it's going to use percentages just like before rather than just frequency counts. So far we've explored frequencies and relative frequencies. Another way we can organize our data is using cumulative frequencies. Cumulative frequencies sum up the counts to the upper boundary in each class. So the last class, by the time we're counting everything, should contain all of the data values. One type of graph that's associated with cumulative frequencies is an ogive. Dots and lines are used similar to in a frequency polygon, but the dots are plotted at the class boundaries. The graph should always increase as you're reading it from left to right. So example 2, this is our cardiogram data again, and we have the class boundaries and the frequency already filled in for us. And this time we're going to come up with the cumulative frequency. So with the cumulative frequency, I'm just adding up the frequencies as I go higher and higher. So for the first class, the cumulative frequency is going to be the same as the original frequency. But for the next class, 10 to 19, I'm going to sum the two classes before. So 1 plus 2 will give me 3. For the next class, I'm going to sum the 3 classes before, so that's 6. And then for the next one, we add on the 7, so that'll be 13. Add on the 4, and that's 17. Oh, 17. And then finally, adding up the 3, that gives me 20. And we started off with 20 values. So this is telling me how many data values are in that class and below. Now that we have a frequency, a cumulative frequency, we can graph our ogive. So remember, the dots are going to be placed at the boundaries, kind of like what we had with a histogram. So our boundaries here, and the negative 0.05, I'm going to kind of stick right here and go with the other class boundaries down here. So 9.5, 19.5, 29.5, 39.5, 49.5, and 59.5. Again, we want to label this is the number of cardiograms. Let's see, our frequency goes as high as 20. So I think we can go by 2s again. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And we'll label this frequency, and of course we want a title. Number of cardiograms each day. For 20 days. Okay, so for our first dot we're at 1. So down here. And then 3. And then 6. And 13. 17. And finally 20. And we connect our dots with straight lines.